Water is actually very rare and precious, and we don't know for sure how it came to our planet. That's why it's so surprising and exciting to find water in places where we least expect it. Scientists have detected water molecules on the surface of asteroids for the first time ever, using a special telescope that flies on a plane above the Earth's atmosphere. This is a huge discovery because it shows that water can survive on dry and rocky space objects, even in the inner solar system where the sun's heat is intense. This also raises some fascinating questions like, how did water get on these asteroids? Did they bring water to Earth when they crashed into it billions of years ago? And can we use them as sources of water for future space exploration? In this video, we will answer these questions and more as we explore the fascinating story behind this cosmic revelation. So, stay tuned and get ready to be amazed by the wonders of water in space. Water is one of the most essential and abundant substances in the universe, but it is not evenly distributed across the solar system. While some planets and moons have plenty of water in various forms, others are seemingly devoid of it. Finding water on these dry worlds is a challenge that requires advanced technology and careful observation. One of the tools that scientists use to search for water in space is the SOFIA telescope, which stands for Stratospheric Observatory for Infrared Astronomy. Unlike most telescopes that are either ground-based or orbiting in space, the SOFIA telescope is mounted on a modified Boeing 747 SP aircraft that flies at altitudes of 39,000 to 45,000 feet, above 99% of the Earth's atmospheric water vapor. This allows the telescope to capture infrared images and spectra of celestial objects that are otherwise invisible or distorted by the Earth's atmosphere. Infrared radiation is a type of electromagnetic radiation that has longer wavelengths than visible light, and it can reveal the presence of molecules that emit or absorb heat, such as water. Using the SOFIA telescope, a team of astronomers led by Dr. Thomas G. Müller from the Max Planck Institute for Extraterrestrial Physics in Germany discovered traces of water molecules on two asteroids, named Iris and Massalia, that are located in the main asteroid belt between the orbits of Mars and Jupiter. These two asteroids are more than 223.1 million miles from the Sun, and they belong to a class of asteroids that are mostly made of silicates, which are minerals that contain silicon and oxygen. Until now, these asteroids were assumed to be completely dry, but the SOFIA telescope detected the faint signature of water molecules on their surfaces. The amount of water detected was roughly equivalent to that of a 12-ounce bottle of water trapped within a cubic meter of soil, comparable to the amount of water found on the lunar surface by the same telescope in 2020. This is a very small amount, but it is still significant because it shows that water can exist on dry cosmic surfaces, even in the harsh environment of space. What does this discovery mean for the theory of asteroid water delivery to Earth? This is a very intriguing question because water is essential for life, and we don't know for sure how water came to our planet. One of the leading hypotheses is that water was brought to Earth by the impact of asteroids and comets, which are icy bodies that orbit the Sun beyond the asteroid belt. According to this hypothesis, Earth was initially dry and barren, but it was bombarded by water-rich objects during its early history, about 4.5 billion years ago, when the solar system was very chaotic and full of collisions. This process could have delivered enough water to fill the oceans and create the habitable conditions we enjoy today. But how can we test this hypothesis? One way is to compare the water on Earth with the water on asteroids and comets and see if they have the same origin and composition. For example, we can measure the ratio of different isotopes of hydrogen and oxygen, which are the atoms that make up water molecules. Isotopes are variants of the same element that have different numbers of neutrons in their nuclei, and they can have different abundances in different sources of water. By comparing the isotopic ratios of water on Earth and water on asteroids and comets, we can infer if they share a common ancestry or not. The discovery of water on Iris and Massalia could help us do that, because these asteroids are closer to Earth than comets, and they could represent the type of asteroids that collided with our planet in the past. However, the discovery also raises some challenges, because the water on these asteroids is not evenly distributed, but rather bound to minerals, or adsorbed to silicate grains. This means that the water could have been altered or lost over time, due to factors such as the distance from the Sun, the size of the asteroid, and the collisions with other objects. Therefore, the water on these asteroids may not reflect the original water that they had when they formed, or the water that they delivered to Earth. What are the future prospects of studying water on asteroids using the most powerful telescope ever built? This is a very exciting question, because we are about to witness the launch of the James Webb Space Telescope, which is a successor to the Hubble Space Telescope, and a game-changer for astronomy. The James Webb Space Telescope, or JWST for short, is a joint project of NASA, ESA, and CSA, and it is scheduled to launch in 2024. It will be the largest and most complex space telescope ever constructed, with a mirror diameter of 6.5 meters and a sunshield the size of a tennis court. It will operate at a very cold temperature, about 233 degrees Celsius, and it will orbit around the Sun at a distance of 1.5 million kilometers from Earth. The JWST will be able to observe infrared light with unprecedented sensitivity and resolution, and it will be able to study a wide range of astronomical phenomena, such as the formation of stars and planets, the evolution of galaxies, and the nature of dark matter and dark energy. But one of the most exciting goals of the JWST is to study water on asteroids and to reveal more details about the water content and composition of these space rocks. The JWST will be able to observe more asteroids with higher quality than the SOFIA telescope, and it will be able to measure the isotopic ratios of water on these asteroids and compare them with the water on Earth and comets. This could help us test the hypothesis of asteroid delivery of water to Earth, and to understand the origin and evolution of water in the solar system. Moreover, the JWST could also explore the possibility of using asteroids as sources of water for future space missions or colonization, as some asteroids may have more water than others, and some may be easier to access than others. The JWST could help us identify and characterize these potential water-rich asteroids, and to evaluate their feasibility and value for human exploration and exploitation. In this video, we have learned about the amazing discovery of water molecules on the surface of asteroids, and how this could change our perspective on how water came to Earth and how it is distributed in the solar system. We have also learned about the methods and instruments that scientists use to find and study water on asteroids, such as the SOFIA telescope and the James Webb Space Telescope, and how they could help us answer some of the most fundamental questions about the origin and evolution of water and life in the universe. We hope you enjoyed this video and that you learned something new and interesting. If you did, please give us a like, share, and subscribe, and let us know your thoughts and questions in the comments below. Thank you for watching, and see you next time.